All right. Hello, everybody. So today we're going to continue talking about Chapter 3, Section 1. We are going to now move into writing the equation of a parabola and finding the minimum and maximum values. Now, both of these things are not too terribly difficult, especially the finding the minimum and maximum values, because that's actually just where the vertex is. And you'll see that here in a second, but it's pretty straightforward. So, um, example 3 that I'm going to start out with is they want you to write the vertex form of an equation of a parabola whose vertex is at 1, 2, and it passes through the point 3, -6. So what they did in this problem is they gave us information about the parabola, but they did not actually give us the equation of the parabola. And so what we need to do is we need to first write the equation of a parabola in vertex form and identify which information they gave us in the problem. And so if you look here, it says the first part, it says write the vertex form of the equation of the parabola whose vertex is at 1, 2. So this 1, 2, this right here is the vertex. Therefore, this number 1 is going to get substituted in for the h, and then 2 is going to get substituted in for the k, because in vertex form, h and k are the x and the y values of the vertex. Now, the other part that we would need in order to just write an equation is going to be this letter a right here. Unfortunately, in the problem, they did not give us the a value. They gave us another ordered pair, which is somewhere on that side piece of the parabola as it kind of slopes out and then goes up or down. So what we have to do then is substitute the 3 and the -6 in for the x and the y. So if you're able to keep track of that, we have a value for h, we have a value for k, we have a value for x, and we have a value for y. What we are missing is a. But we need a to actually write the equation. So what we're going to do is we're going to substitute those values in for h, k, x, and y, as you can see that I did there, and then we're going to solve this for a. Now, in doing so, you're just going to follow PEMDAS. So first, we're going to go inside the parentheses. We're going to do the 3 minus 1, which is going to give me 2. And from there, I'm going to square that 2. And that's going to give me a 4a. Notice everything else stays the same for right now. The -6 comes down, the 2 comes down. Now from here, it's just a matter of solving a two-step equation. You did a lot of these in Algebra 1. You're going to subtract 2 from both sides, and then you'll divide by 4, and you will get a equals -2. So again, the two most important pieces of information that we need in order to actually write the equation is we need h and k, and then we also need the a. They did not give us the a in the problem. They gave us another point. So we had to go through, plug it into the information that we know, and then solve for a. So now that we have our vertex, which is at 1, 2, and we have a, which is -2, we can then proceed to substitute the h and k, 1 and 2 in for h and k, and the a in, and write our equation. And you can see right there, once I put -2 in for a, I put 1 in for h and 2 in for k, I now have my equation of the parabola. This equation is in vertex form. One thing to note, this parabola will open down, and it opens down because the a value is negative. So not so bad. It's really not a terribly difficult problem. Here's another problem. This is example 3b. It's identical to the last problem. They give you the vertex, -4, 11, and then they give you a point, -6, 15, that is on the parabola. And we need to use this information to write an equation of the parabola. And so we start with vertex form. We substitute in the h, so -4 goes in for h. Notice it becomes a double negative because it would be minus -4, so it becomes a +4. The k is 11. This -6 goes in for the x. This 15 right here goes in for the y. And you can see all of the variables are substituted in except a. And so then we're going to follow PEMDAS again and solve for a. So we're going to go first by simplifying the -6 plus 4, turns into -2. Then we're going to square that, which will give me 4a plus 11 equals 15. I'm going to subtract 11 from both sides and then divide by 4. And there again, I've gotten the value that I needed for a. Once I have a and I have my vertex, that is the information that I need to write an equation of a parabola. And so I substitute 1 in for a, and then I substitute -4 and 11 in for h and k, respectively, and you get this y equals 1 times parentheses x plus 4 squared plus 11. So the next problem that I want to show you is how to find the minimum and maximum values. Now, this looks a little bit scary, right? There's a lot of math going on here, but this is actually something that you already knew how to do from Algebra 2. And in Algebra 2, before you learned about vertex form this year, in order to find the vertex of a parabola, you use the formula -b over 2a. And I even talked about that formula in an earlier video, but the one that you actually watched hopefully yesterday. But this formula -b over 2a gives me the x value of the parabola. And then once I have that x value, I simply take that x value and plug it into the equation to get my y value. And then once you have both the x and the y, you have the ordered pair of the parabola, of the parabola's vertex. So the one thing that you need to keep in mind is if you have a parabola that opens up, it does not have a maximum value. These sides go up forever, but it does have a minimum value down at the vertex. Flip it over, and you end up with an upside down U. Once again, these things go down forever, but it'll come up and eventually peak and then go back down. And that top point right there is considered the maximum value. So a parabola will either have a maximum or a minimum. It cannot have both. And whatever it has is dependent on which way that parabola opens. So if it opens up, it has a minimum. If it opens down, it's going to have a maximum. And so using that thought process, we have this word problem that is asking us for the maximum height of a baseball. Now it says the path of a baseball after being hit is given by the function f of x equals -0.0032x squared plus x plus 3, where f of x is the height of the baseball, and then the x value is the horizontal distance from home plate. So if you can imagine for a second, our coordinate plane is a ball field, and the home plate is the origin. And the further that ball goes away from home plate, the further that ball's running along the x-axis. The distance that that ball is off the ground is going to be your y-axis. And so what they want us to do is find the maximum height. So the maximum height is going to occur at the vertex of this parabola. And so there's a couple things now that we should know about this parabola. First of all, it is a parabola because it's an x squared. So we know that it's going to form a parabola. The second thing that we need to know about this is that this lead coefficient right here, this -0.0032, is indeed a negative number, which means the parabola will be upside down. And that should make sense to you if you think about what a path of a baseball looks like when it's hit. It's hit, it's going to go up, and then it's going to come back down. And so we want to find that height, that maximum height of the ball, and that's going to happen at the vertex of that parabola. So in order to find the vertex of this parabola, you simply need to use the formula -b over 2a. I'm not going to make you put this one in vertex form. So the formula -b over 2a will give you the x value of the parabola. Now keep in mind, x is the horizontal distance from home plate. We want to know the maximum height. So in order to get the maximum height, once you find that x value, you have to plug it back into the equation to get f of x, which is the height of the baseball. So here's the quadratic equation. This is the standard form. This is the one we were given. And you can see that a is -0.0032 and b is 1. So in the formula, we're going to use -b over 2a. Again, this formula is a formula you learned last year in Algebra 2, and this formula gives us the x value of the vertex. And so when I plug those numbers in, so negative 0.0032 for A and 1 in for B, I get negative 1 over 2 times 0.0032. Simplifying that will give me the value of, and if you type this in your calculator, if you don't believe me, but it's going to give you the value because it looks like these numbers are really small, but when you divide by a really small number, you get a large number. And so we get 156.25. Now, again, this number is the x value in the problem. So backing up into the word problem for a second, x is the horizontal distance from home plate. They want to know what the maximum height is. So in order to get the maximum height, we have to take that x value and substitute it back into the original equation. So once I get this value of 156.25, I then plug it back into the original equation. You can see everywhere where there was an x, they substituted 156.25 in. And then typing that in your calculator, you will find that the maximum height of the ball is going to be 81.125 feet. And that happens at 156.25 feet away from home plate. So that's what I have for you today. I appreciate your attention. As always, if you have any questions, feel free to email me. Have a great day.